Now that we have learned a little bit about parent functions and what they look like and how to what a linear function looks like, what a quadratic function looks like, let's talk about something called domain and range. There are a few definitions that you need to write down. You need to know all of these. Hopefully you know what an ordered pair is by now, but just in case, there is the definition for ordered pair, domain and range, and then continuous graph and discrete graph. Domain is the set of all possible input values of a relation or a function, or it's the x values. That is the important part of that definition, is that it is the x values right here. So domain is always x, and then range is the set of output values, or y. So domain is x, range is y, and that will always be the case no matter what. Continuous graph and discrete graph are also very important, and continuous graph is a graph that's made up of continuous connected lines or curves, so all the points are connected, and then the discrete graph is just unconnected points, or it has gaps. It's not, you can't put your pencil at one end and follow it all the way to the other end without having to pick it up, is what I mean. So if you would, please make sure you write down these definitions. You'll probably have to pause the video, but write down these definitions so that you will have them. Domain and range are the very, very most important ones. You need to know that domain is all of the x values of a function and range is all of the y values. So let's just talk about this. We're going to do domain and range from a graph, from a picture, and everything we do today, you will be given a picture. It wouldn't hurt for you to sketch the picture. I will also post a copy of this little slideshow in PDF format onto Edline for you, so that you can go get it and print it if you need to, so that you will have a picture of the graphs. Sometimes that might be easier, but if not, just sketch the graphs. Otherwise, you can go get a copy of this presentation off of Edline so you can see the pictures. Okay. Our first graph here, you see, it's nothing but dots. It is not connected. You just have 5 separate little dots. And so this right here, where it asks continuous or discrete, this is a discrete graph because none of the points are connected, and I have to pick up my pencil to get from one point to the next. Now, we're going to list the ordered pairs first of all for this problem. So we're going to have to write out the ordered pairs for each of these 5 points. And so here's how we're going to do this. We're going to do it as a set, so we're going to do this little squiggly bracket. It's one of these little things, and people have trouble making them. If you have trouble drawing a squiggly bracket, you can do an S and an S on top of it, and that's close enough. Or you can just do a squiggle, but somehow you need to represent that it's a set of numbers, and so you need to do the squiggly bracket. Don't just draw a bracket, it means something different. And then we're going to list our ordered pairs. We will always go left to right when we do a graph. And so this point over here way on the left is over 1, 2, 3, 4. So it's at -4, +2. This ordered pair right here is at -2, -1. This one right here in the middle is at 0, -2. And this one right here is at +2, -1. And this one right here is at +4, +2. And then we close the set. So there are the ordered pairs for that graph. They are listed out from left to right, so that at least the domain goes, or the x values go from least to greatest. The next thing we are asked to do is to write the domain for this graph, for this function that is graphed right here. You saw when we did definitions just a minute ago, the domain is the set of all of the x values. So when I write domain for this, because it's a discrete graph, I'm going to list out every single number. And so it's a set again, because it's going to be a set of numbers, and I'm going to list all of the x values. Well, my x values right here are -4, -2, 0, 2, and 4. None of them repeat. So I need to list them all out. And when you list them all out, you have to put them in order from least to greatest. If you don't put them in order for least to greatest, it's not correct, and you'll lose points when you take a test or do homework. Another thing to remember, and when we come across one, I'll show you, if you have values that repeat. In other words, if the -4 showed up in this ordered pair and in this ordered pair, you never list repeated values. If the -4 shows up more than once, you still only write it once. So our domain, all the x values is -4, -2, 0, 2, and 4. That is our domain for that graph right there. Our range is all of the y values, and it works exactly the same way. You have to put it in order from least to greatest. The the range usually takes a little more work. You can't just write them in the order they are. You've got to make sure you put them in order least to greatest. And again, we do not write any repeated values more than once. So once we write the number -1, we will not write it again, even if it shows up again. So here are my range values. I have -2, -1, +2, -1, -2, -1, and +2 again. Well, the +2 repeats, and so does my -1. So when I write it down for my range values over here, I'm only going to write those numbers down once. The smallest number of those three numbers that I named is -2. And then I have a -1, and it shows up twice. It shows up in this ordered pair and in this ordered pair, but I'm only going to list it once. And then +2 is my last one, and even though it shows up twice, I only list it once. The reason why is you're saying that my range is all of these numbers, -2, -1, and 2. Well, if I've already said that the range is at -1, there's no reason to say the range is at -1 again. You're just repeating yourself, and that's unnecessary. So we never list repeated values. Okay? So there is your domain and your range for that function. Now, if you look at the next graph, it starts here with a dot. It's a closed circle. And if I went all the way around here to this open circle dot, my pencil could stay touching the graph the entire time and I'd never have to pick it up. So this is a continuous graph because all of the points are connected and there are no gaps. We are not going to list the ordered pairs because it is a continuous graph. So we're just going to write the domain and range. And there are two ways to do this. I'm going to show you both. One is to write it as a set. Okay. It's to write it as an inequality. And so one way is to state that the domain is all of the values between here and here. And so we write it as an inequality. The other way is to write it in interval notation. I'm going to show you both because you need to be familiar with both. And you need to be able to write both and recognize both no matter what. So our domain we learned is always the x values. And if we look at our graph, we're going to start on the left and go to the right. This point right here, it is a closed circle, which means that this point is included as part of our graph. And so when I deal with this number, it's going to be included. And we did this with compound inequalities, so this shouldn't be totally new. The x value at this point is at -4. And so my domain starts at -4 and goes all the way over here to this open circle, which means it is not included as part of my graph. But this open circle is at 8. And if you'll remember, okay, x is all of the numbers in between here and here, okay? So it's less than all of these numbers, but greater than all of these. But my inequality symbols have to face the same way. So x has to be less than 8, and it is only less than 8 because I have an open circle. But at -4, I have a closed circle, so it is less than or equal to is my symbol here. And so this means that x is in between -4 and +8 with -4 included. This is the inequality notation. The other way that you could write this is in interval notation. And to write this in interval notation, it is a little bit easier. My numbers go from -4 to +8. +8 was not included. It had an open circle, so I put a parenthesis. -4 was, so I put a bracket. These mean exactly the same thing, but you need to be familiar with both representations. So I'm going to use both as we go through the notes. Now, range is our y values, which is up and down. When you do range, we always go bottom to top. The bottom point all the way to the top point. And again, we're going to write it two ways so you can see. Now, our bottommost point here on our graph is at this -2. Now, there is something we need to talk about because there are 2 points at -2. There's one right here, and then the open circle one right here. This point right here at -2, the graph actually passes through there. There's not a hole, there's not a gap, there's not an open circle or anything. And so it actually passes through. And so since there is actually a point here, it overrides the open circle. So -2 is my smallest point on the graph, and it's included, so it gets the less than or equal to. My highest point on the graph is up here at +2, and there are 2 points here, but they both are included because you have a closed circle and then you actually have a point. And so it is also included, but it goes to +2. And so my range is all of the y values between -2 and +2 included. And so if you want to write it in interval notation, you have a bracket on both ends. So let's try a couple more. Okay, this graph right here is different than the two that we just did. Number one, it's a continuous graph. So when we want to label it as continuous or discrete, it's continuous because there are no holes or gaps. But it has arrows on the ends instead of endpoints. And that is going to change how we look at our domain and our range. Because this graph, you should know the arrows mean continue on forever and ever and ever in both directions. Continuous graphs, we don't list ordered pairs. We're just going to do the domain. So the domain of this graph goes from the left to the right because it's x values. This arrow right here means that this graph continues in this direction to the left and up as forever and ever and ever. So my endpoint of this is actually at negative infinity because it goes on forever. And my endpoint over here to the right, because it goes up and to the right forever and ever, is at positive infinity. Now, something you may not know, infinity is not a number. It is only a symbol to represent that something continues on forever. It is not a number, okay? You can't add something to it or subtract from it. It's just a representation that something continues on forever. So you cannot include infinity in your graph because it's not a number. So when you do your symbol, it has to just be less than. It can't be the or equal to. And if you write it in interval notation, infinity, no matter what, always has a parenthesis and not a bracket. Now the range for this graph is just a little bit different because you remember range goes from bottom to top because it is the y values. This graph actually has a bottom point. It has a bottom point at -2 and there's actually a point there, so it's included. But the arrows mean it goes up forever and ever and ever, so it continues on to positive infinity. So it goes from -2 to positive infinity, and that -2 is included, so it gets a bracket. Another way to say this, just so you know, whenever you have the negative infinity to positive infinity, it means it includes all numbers that we can think of. We say that it is all real numbers. And so you either write out the phrase, all real numbers, or there is a symbol. It's an R with a little double thing on the back. That means all real numbers. You could write one of those as well, but you need to be able to recognize that this means from negative to positive infinity. Now the next one, I have a linear function. I've got a straight line here. This is a continuous graph because it goes from here to here, so I do not have to write the ordered pairs. My domain for this graph goes from this hole to this hole. So I've got open circles at either end, which means my endpoints are not going to be included. And so it goes from -1, not included, to +2, which is also not included. So x is all of the values between -1 and +2. And somebody reading this would know that I have a straight line that goes from -1 to +2, not included. And so in interval notation, it would look like this. And then my range goes from here all the way up, and so it looks like 1, 2, 3, 4, 5, 6, -6, not included, all the way up to +1, 2, 3, 4, 5, +6, also not included. And so in interval notation, it looks like this. So my y values are all of the values between -6 and +6, with those numbers not being included. So let's just do two more. These are kind of important because these are special. Okay, I have a vertical line here that you can see continues on and on forever. This is a continuous graph because there are no holes or gaps, so I will not list the ordered pairs. My domain for this, the domain has to go from left to right. Which values does it cross through going from left to right? Well, this graph doesn't go left to right. But if you'll remember by definition, domain is all of the x values. So look at this graph. What is the only x value it passes through? The only x value this graph passes through is 1. So the domain of this graph is x equals 1. That's it. Okay? If you wanted to, and that's it. X is 1. That's your domain. It doesn't go anywhere else, and 1 is included, so you're good. Your range, however, goes in the negative direction forever and ever and ever, and it goes in the positive direction up forever and ever and ever. And so you've got arrows on both ends, which means it's one of these negative to positive infinity graphs. And so either notation, it goes from negative to positive infinity, or you could say all real numbers. This one is also special. Continuous graph, as I don't have any holes or gaps, my pencil could go all the way across. And so we won't list ordered pairs. Now your domain is all of the x values. And so this one, it looks like it goes from -2, and -2 is not included because of the open circle, all the way to +3, which is included because of the closed circle. And so here are the two ways that you would see that written. But your range, it doesn't go up or down at all. But it does cross through a y value, and you should notice that it crosses through y equals -6. So that is your range. So that is domain and range. We will practice this tomorrow, and I will see you then.